welcome back. In the last two sequences of this week we will look at functions in OCaml. We will explain in much greater details all the mechanisms about functions in week 4. For the moment in this week I will just try to explain to you how you can define yourself your own functions in OCaml. In fact, there is nothing special about functions in OCaml. Functions are in reality values as any other value in OCaml, but we will see this in detail during week 4. Now, in order to define a function f, let's say with one argument, you would just write down let f x equals the expression, and expression would be the body of the function, which in general, of course, would use its parameter x. You can also write down a local definition with a scope delimited to expression 2 in this case, and you would write it like let fx equals x1, its body, in x2, its scope. The scoping rules would be precisely the same as we have seen in the last sequence, which means that local definitions always take priority over more global definitions. As we have seen already, you would write a function application just by writing its name followed by the expression which gives the value of its actual parameter, and you just have to use parentheses if it is necessary to indicate structure of expressions. Now let's look at some simple examples of function definitions. First we have a global function definition that f equals x plus 1. And we see that f is recognized as a function with type int, arrow int, and of course we may now apply this function to an argument and obtain the value as expected. The next example is just the local definition variant of a function definition. Here we have a local definition of function g, which would only be known in the expression after the in, and it also works as expected. Finally, you might in some cases obtain something not expected when you try to write down something which can be interpreted as a sequence of function applications. Like in this case, f now is defined as a function with only one argument. So when we try to pass this to the top level, we obtain in fact an error which we haven't seen before, since OCaml is telling us that we tried to apply a unary function to too many arguments. Why? Well, in fact what happened here is that what we wrote on this line is that we tried to apply f to two arguments, namely f, and then to a second argument which is 1. And this is of course not what we meant to write. The only thing which makes sense in this line is to apply f twice to the value of 1. And if we want to apply functions in this order, then we have to use parentheses in order to indicate the correct structure, and when we do this we obtain what we expected. OCaml, as almost all modern programming languages, is governed by the principle of lexical scoping. This is a very fundamental principle of modern programming languages, so let me spell it out. If you write the definition of a function and you use in the body of the function the name of an identifier, then this name always refers to the identifier which was visible at the moment of declaration of the function, and not to the one which is visible at the moment of execution of the function, which would be the opposite principle of dynamic scoping. Now I wish to demonstrate to you the very important principle of lexical scoping, which we have in OCaml. Lexical scoping means that when you have a function definition, like here the definition of g, then the f that you see in the body of this function definition is the one which has been visible at the moment of this definition, which means the one defined on line 2, and it's not the one defined on line 4, even if we have an application of g which comes after this second definition of function f. So when we pass this phrase to OCaml, we see that the f which will be used by the function g is in fact the function which maps x to x plus 1, which means that we really have the principle of lexical scoping on this example, and we obtain, applied to 5, of course, the value of 7. If we had dynamic scoping, then the f used in the execution of function g would be the function which doubles its argument, that is, you would have obtained a value of 20. We have precisely the same thing when we use global definitions instead of local ones. So here is the same thing, exactly the same kind of example, only expressed with global definitions, and we obtain precisely the same result. As we have seen in the previous sequence, you are allowed to give several definitions of identifiers using the same name. As I have explained to you in the last sequence, this just means that you give a new definition of a new identifier which might locally shadow a previous definition. In any case, this must not be confused with the changing of the value of a variable as you have it in traditional imperative programming languages. Now, using the principle of lexical scoping or static binding, I can in fact give you a demonstration that this really is the fact. So now, using the principle of lexical scoping, I can give you the demonstration which I promised to you on the previous sequence, namely that if you do twice a let binding on an identifier with the same name, then this is not an assignment, but really a definition of a new identifier. Now, to show this to you, let's first make a binding for an identifier A. Then let's define a function f which uses in its body this identifier A. Okay, now we have defined f. F is now the function which sends an x to x plus a, that is in this case x plus 1, and of course if we apply this function to the value of 2, we obtain the value of 3. Now, to demonstrate to you the fact that adding a new binding for identifier A really gives a new identifier and doesn't change the value of the old identifier, let's just pass now a new binding for A, like here, say the value of A to be 73. When we do that, and when we call now upon function f with exactly the same argument, we obtain still exactly the same result, which proves that the second A which we have defined is a new one, which just is not visible at all by the function f which had been defined before.